So this is B block chemistry, Monday, October 5th. All right, so, oh, I forgot to sorry, y'all. My setup got kind of messed up over the weekend. Gotta readjust. Okay. So let's see what today's agenda is. Yay. Okay, let me pin my video so that the recording sees that. Alrighty, so some housekeeping, y'all. I am in the deep thick of updating grades. And I recognize that y'all can't see your grades on what's it called, on Assignment Center Blackbaud. So I know some other teachers do this as well. They make like a spreadsheet where you only have access to seeing your grades on the spreadsheet. So I'm in the process of doing that so y'all can actually see your grades. I think that's really important, especially for how like chaotic this semester is. Y'all, I know I sent out like a bajillion and 5 like requests on Quick Drive. Please put all your work in that original shared folder I gave you, okay? Not one that you made. Otherwise, it's really hard for me to find it. It turns into a mess. Please, like, go make sure, like right after class, or like honestly, like right now, I'm fine with you if you do it right now. Go to your Quick Drive, make sure that all the work, so the lab writing practice, the gummy bear lab, the in-class worksheet from last week, make sure all that is in that folder, please. I'm going to say this like 50 more times. If I can't find it like in the future, I'm going to start taking points off because it just becomes a nightmare. So please, shared folder, please. Okay, y'all might be wondering, like, how is a test gonna happen in this class? Like, especially with all the change going on and like the hybrid and the distance. So I do not plan on giving you a kind of standard like test for the material we just learned. Like here's a sheet of paper and it's multiple choice and stuff. No, I'm not planning on that kind of standard test format. I'm looking more at a project to get y'all like involved with the material. So, long story short, this isn't going to happen. This isn't going to come together until like later on this month, okay? And that's because with next week being like it's going to be a lot of change. I'm not going to throw a project on top of you that week, okay? So just hold tight. It's going to come together. So try not to worry about that. All right. How are we doing? I'm actually really curious. Have any of y'all learned like something super cool in your other classes? Like, I don't even mean like other like science classes. Like, I mean like any other one. Like, anyone learn something cool you want to share? I like learning about other things. So, anyone want to go? Any like, was there like a good poem you read, or like, oh, what other classes? I feel like saying, was there a cool math problem is not something y'all are going to say yes to. All right. Okay. I won't make you share. But if you come across a good poem or something, feel free to send it my way. I like reading. So, hey. All right. Next, we're going to do our warm-up questions. And today, the warm-up questions are actually going to be checking your work from last week. I want to make sure that we're all on the same page, that we understand the answers. So go ahead right now, go to your Quick Drive and find the in-class worksheet from last week on mixtures, elements, and compounds. I am going to send you the answer key, and y'all, all this now lives in the Quick Drive folders, so you can re-access them. So I'm going to send that to you now. I'm going to send it to you in the chat. We're not going to do breakout rooms for this, y'all. Okay. So we're actually just going to look at it together. Okay, just run through it. If you have questions, then say something. Okay, so I'm going to share a screen to the answer key. Again, this lives in the Quick Drive. All of these materials live in the Quick Drive. All right. So we saw this nice flow chart that categorizes matter either as a pure substance, so basically just one type of thing, or a mixture, which is two or more types of things. So in pure substances, we can have either an element or a compound. In a mixture, we can have heterogeneous mixtures or homogeneous mixtures. What is another word for a homogeneous mixture?
Solution.
Nice, thank you. I feel like we're all tired today, and that's okay. Okay, good. Another word for a homogeneous mixture is a solution. So technically, air is a solution. All right. Okay, so. I'm not gonna go through literally all of these because y'all already did that. But I do want to look at kind of the tougher ones to make sure we understand those parts. Okay. So, okay. So we just said air is a mixture. It's a solution. It's a homogeneous mixture. Sugar water. Okay. Sugar water is the act of mixing sugar into water a chemical or a physical change? You got a 50-50 shot.
Wait, what was the question?
Is mixing sugar into water, so this one, right? If I can highlight, it won't let me highlight, that's good. Okay. Sugar into water. Is that process a physical or a chemical change? I think I saw Ryan's hand first.
Oh,
It's a physical change because there's nothing that's being changed about like the actual chemical. It's just like, I don't know.
I love like the ending there. Yes, you're totally right. Great explanation. At the end of the day, when we mix the sugar and water, we still have sugar and water. It's just mixed, right? Okay. Milk and cereal. So this is a mixture. We have two separate things coming together, and it's heterogeneous because you can see distinct layers. Inti, yes, do we have a question?
sorry, that was an accident.
It's cool. Don't worry. Okay. Milk and cereal is a heterogeneous mixture. How many phases does this mixture have? I'm looking for a number. So what is the definition of a phase? Give you a hint. A phase, another way to describe it is a distinct layer. So how many types of distinct layers do we have in your cereal bowl? Can you give me like oh wait, Inti, yeah.
2.
Yes, okay, wait. You're right. Can you explain why?
Because the cereal and the milk don't like chemically mix, like they just kind of stay apart. So it's like the first layer, which is like the milk, and then the cereal on top.
Good. So this is similar to the example of like sand and water, right? Like there's a distinct layer of sand, and then there's the layer of water, or the phase. Nice. Okay. Number 2. I really like number 2. There we go. Okay, whatever. That's as good as it's going to get right now. I really like number 2 because it makes you conceptually think about what's going on. So, okay. Do we feel comfortable with number 2? This one's kind of hard to talk about over Zoom. So do we feel comfortable with it? So A is one type of compound, because we can see the different colored circles coming together, but they form the same type of thing. B is two separate elements, so a mixture of elements. C is just straight up one element, is just one type of circle. D. So we notice that each specific little blobby fixture, it's either made up of like, oh, I don't know how to describe the shape, y'all. It's either like this kind of reminds me of like a hot dog shape or like a little fan shape. So it's a mixture of these two compounds. And then E is the fun one. E is a compound. So imagine this little hot doggy shape right here. That's a compound. We have two separate colored atoms coming together. And then we have an element in there. So this is an element, the little two white circles, because it's just one type of circle. We good there? Questions? Wait, NT, do you still have your hand raised from before, or is this new question? Sorry, thanks. All right, okay. So y'all, for this final question, I did go through your work, and I did comment if I thought that you did not provide enough of an explanation. I actually do go through your work and like read your stuff. Some of y'all gave me too simple of an explanation. You basically kind of said, we separate out the water from the salt. Well, yes, that is the whole point of this system, to get fresh water on your stranded island. But I really wanted you to explain what was happening. You didn't have to write me a paragraph, but I just wanted to see that you understood, hey, we can use the physical property of a boiling point to separate out the water, turn it into a gas, and then turn it back into a liquid. Side note about comments on documents and stuff. So if it's on the Google, like if it's in the Quick Drive, I directly leave a comment on that. If it's an uploaded PDF to Assignment Center, I do try to leave comments on that as well. And then within Assignment Center, there is a comment function for each assignment. And I do try to leave like solid feedback for you on that. I have heard y'all are not able to see the comments like directly on the Quick Drive. I mean, the Assignment Center. Is that true? We'll check later, okay? Because oh, sorry.
What do you mean by comments on the page?
So, okay, how to word this, y'all? When
like
you
on a Google Doc?
No, so I don't want to pull up my grade book and like show people's grades, but what I mean is that on each submission into Assignment Center, there is an option for me to leave a comment on that submission, not the actual document, but within Assignment Center. Are y'all able, like, I know y'all can't see the grades on Assignment Center. Can you at least see my comments?
No.
Oh my gosh, dang it, y'all. I left y'all like such like, oh, dang it. Okay. I will figure out how to make that work, because it's important to me that you actually see my feedback. Because, and I don't mean that in like, you know, oh, you better see my feedback. Like, y'all, for the most part, you did great jobs on all these assignments. And like, I like leaving positive feedback too. Let me figure out how to fix that so that you can see it. All right. Okay. So today, y'all, we are jumping into, oops, sorry. Looking at the stuff. Today, we are jumping into actually a new chapter. So in your chemistry textbook, we have just finished up chapter 2, which is like intro to matter, stuff like that. And we are looking at chapter 3 in your textbook, which is scientific measurement. This is a chapter that I know a lot of y'all are like hesitant about, because basically this is our introduction of math and chemistry. But I want to kind of take that anxiety away and instead make you feel empowered through it. Hopefully, it's okay if that doesn't happen all today. But today, yeah, we're gonna jump into looking at some math. So for the next class, like today, this week, and honestly from now onward, make sure to bring your calculator. And additionally, y'all take notes. Like I'm going to give you material where some of it is summarized on like a document, but take notes, work through these problems with me. I do not recommend you work these problems out on a Google Doc. I recommend like paper, like at a table, you write it out. Yeah, because like you're eventually gonna have to know how to write it out, like not on a Word document. Okay. Alrighty. So what I'm gonna do now is oh, actually, let me show y'all on the topics pages. To be honest, I don't even know if y'all like check the topics pages, but that's fine. It's there as a resource anyways. I want to show you that it has been updated for this next unit. There's the self-care as always. And we are now on to Unit 2, Scientific Measurement. And does anyone actually know what this picture is of? So it's this scientist lady. Does anyone know what she's doing? Elia.
I'm pretty sure she's using a pipette, but she's like blowing, she's like sucking in.
She is mouth pipetting. Y'all, this is like like we do not do this anymore in our lives. Like we do not, because actually, like can you imagine if you had to literally suck up into like basically a glorified straw, like blood or ethanol or chloroform? Like we don't do that anymore. We have special pipettes that we don't suck liquids out from. But like isn't this cool though? Like this is how they used to like draw up certain volumes of stuff, right? Like draw up, you know, like 50 milliliters of a patient's blood by mouth. So we've come a long way with instrumentation. So yep, okay, so QuickDrive updated if you need that, if you look at it, if you prefer it. Okay, let's get into the actual stuff now. So we're gonna be taking notes, okay? And I didn't want to do a guided lecture video on this because I want you to be able to stop me and ask questions, okay? So let me go to this. Okay, there we go. Wait, that is too far away from me. Sorry, y'all. My entire setup got messed up and now it's hard to readjust. Okay, there we go. So today, we are in chemistry class. We are now on Unit 2, Scientific Measurement. Again, this is in your textbook, Chapter 3. So if after this class you're like, I kind of don't remember a lot of this, go back to your textbook. They have some good examples there. This lesson will focus on two things. Let me zoom out. This is a little bit too zoomed in. There we go. Okay, good enough. We will focus on scientific notation and standard, sorry, that's an A, standard notation. I'm gonna draw a divider. I like drawing dividers to make it clear where we're stopping. Okay. So, sorry again, y'all. Everything got messed up. my dogs like ran into the table and everything fell off. So why do we need to learn this stuff anyways? Like, why is it relevant to chemistry? Well, in chemistry, we like to quantify things, right? Think of quantitative data. We like to quantify the world around us. And to do this, we take measurements. And y'all, this may seem basic, like you're like, oh yeah, to like analyze stuff around us, we got to measure something, right? But I want us to start thinking about how and why. We do this a lot in our daily lives, just kind of offhandedly, but I want us to think more analytically for chemistry. So measurements, the technical definition for a measurement is a quantity with a value and a unit. So an example might include, if you're measuring the length of something, let's say that whatever, my dog is 2 meters long, right? So we have a value and a unit. Or maybe something like volume. So in chemistry, we really like to think about volume. Maybe the gas in a container takes up 5 liters. So we use big L for liters. Alrighty, so we take our measurements to analyze the world around us. But when we actually want to compare these measurements or apply them in some way, we use certain conventions to make our life easier. So use conventions to make life easier. An example of this is when we use scientific notation. Okay. Also, y'all, if I move the sheet of paper too fast, yell at me and I'll hold it there so you can finish writing. Alrighty, so scientific notation. Let's actually define like what really is this term. So, scientific notation. So here is my kind of slang definition. Like, this is not exactly how your textbook will say it, but I think it makes a little bit more sense when we first learn it. Scientific notation is a shorthand for expressing very large, oh y'all, I'm sorry, this is, there we go, it's better. Very large or very small numbers. And we write it in a specific way because that's how it goes for this convention. The way we write it, the way it is written as, looks like this. We have a number called the coefficient. And that number, that coefficient, is multiplied by 10 to some power. There we go. This looks kind of abstract right now, but we're going to go through some examples that will clarify this. The coefficient, this number, we write it as a number between 1 and 9. The power, so 10 to the power, right? So this number, the power, can either be negative or positive. And depending upon if it's negative or positive, it tells us, it describes the magnitude of the number we're looking at. So again, if this doesn't quite make sense yet, that's okay. We're going to look at an example and dissect it for each of these parts. Questions so far? I'm sorry, hold on one second. Jasper, stop licking the floor. I love my dogs, but like they're real dumb. So let's go into an example. Example number 1. I want to look at the width of the universe. Okay, y'all, make sure you write tiny for this, okay? You may want to wait for me to actually write this out first so you can judge the space you need. The width of the universe is approximately 8, and then 27 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 meters. That's our unit. It's the width of the universe is this many meters. Let's say that you're like, your job is to like look at space and stuff. Do you want to have to write this entire string of numbers out every time you want to talk about the width of the universe? No, I don't even want to write this a second time after writing that out. So what we do is we write this in scientific notation so that we can express this super large number in a more convenient way. What I'm going to do now is I'm actually going to send you a document over the chat. It's some practice problems and some, I can't multitask. Sorry, y'all. I can't multitask. Okay, chat. This is a PDF, and I'm specifically giving you a PDF so that you write these examples out on paper yourself instead of using the document. So let's actually look at this for a second. I have given you on the first page, let me switch to this. On the first page, I have given you steps for writing a number in scientific notation. I didn't want to spend 20 minutes of class just writing this out. So here you go. If you want to, I would suggest if you're able to like print out a copy and paste it into your notes or tape it into your notes, that's what I actually do. Or if it helps you to handwrite it, write this in your notes. But I suggest put this in your notes, rewrite it somehow. Steps for scientific notation. There are 3 main steps. So we're going to look at these steps and then apply it to the width of the universe. Steps where would you put the decimal value to make the number between 1 and 9? This gives your coefficient. How many decimal places did you have to move the decimal to get that coefficient value? This gives your exponent, so 10 to the whatever. Then we determine the sign of the exponent, if it's positive or negative. So let's look at that width of the universe. So I'm going to walk through this one first, just so y'all see an example. So I notice that I have like a ton of zeros, and then I have, basically it looks like an 88, right? Where could I put a decimal so that this number now is looks like it's between 1 and 9? And the answer is that I'm going to put the decimal here. So basically 8.8, right? That's between 1 and 9. Okay. So the decimal originally, sorry, getting a thinner marker here. Oh, no. Otherwise it's going to be hard to see. Let's use purple. Okay. Originally, the decimal place started down here. Y'all, I actually still do this method, like to this day. This is how I do it. I actually draw little loopies between each digit to count how far over I move the decimal. So I had to move it 1 place, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I had to move the decimal place over 28 times to get it from where it started to our coefficient. And y'all, for real, like I do this on my paper. Like there's no shame in, in like drawing these loopies and like remember, yeah, Winter, yeah.
But isn't there like an easier way to do that? Like, could you just, like, if it's 27 zeros, could you just like add 1, I guess?
Yes, you are technically correct. If you are familiar with this enough, you can kind of say, well, if I have 27 to the end, then I can, I know how many it would move. But I'm showing y'all like from like, we're building up from the bottom, right? Like we've never seen this before. Let's get a solid understanding. This also just honestly helps me like count to make sure I like wrote it down correctly. So, okay. Our coefficient is now 8.8. Coefficient. This is now times 10. 28 is now our power, so 10 to the 28. And now we have to decide if this is going to be a positive 28 or a negative 28. So go back to those rules. If your original number was greater than 1, the exponent is positive. If your original number was less than 1, the exponent is negative. Our original number is most certainly greater than 1. It's a very large number. That means that this 28 is going to be a positive 28. What I want you to start thinking about is if this exponent feels like a big number or a small number. So 10 to the 28. Y'all, that's a ginormous number. We're going to look at another example of a negative exponent. So questions about this? I know it seems pretty tedious, but we got to get a solid foundation on it. Okay, let's look at a second example. Alrighty. So example 2. So someone had to take this, someone had to measure this. The human hair has an average diameter of 0.00007 meters. Y'all, someone had to measure that on a microscope. Express this in scientific notation. So again, step 1, move your decimal to make a proper coefficient. So I can go 1, 2, 3, 4, 5 to the right. So I have 7. That's our coefficient, 7 times 10 to the 5. But then we ask, is this positive or negative? The number we started out with was below 1. And another pattern you're going to see is that if you move the decimal place to the right, it's a negative exponent. In the previous example, we moved the decimal to the left, so it's positive exponent. You can look at this in slightly different patterns. Y'all, whatever sticks in your head, whatever helps stick it in your head. And this is meters. All right, so what I want you to do is, sorry, thinking about time, thinking about what I exactly want y'all to cover. Okay. Oh no, sorry, 1 second. My computer is dying. It's not good. Okay. I want y'all to work on part A and put these numbers into scientific notation. I'll give you a minute for that, okay? Oh, I forgot to ask, does anyone have questions at this point? I know this seems very tedious, but...
Do we have to turn this in, the worksheet?
No, but you are gonna have to finish other parts of it for homework.
Okay.
So this is not the homework portion. Alrighty, so what do we get for, sorry y'all, getting more paper. What do we get for number 1? So what is our coefficient for number 1? Yeah, Al.
The coefficient for the first one is 3.47.
Good, 3.47. Can anyone tell me times 10 to the what? Oh, I see some hands. I see Cece, yeah.
10 to the 5th.
Good, 10 to the 5th. Yay, y'all got this. Okay, 2. Okay. So what do we get for our coefficient for number 2? Kayla, yeah.
I got 9.02.
Boom, you are totally right. 9.02 times 10 to the 8th. And then, Winter, would you like to give me the coefficient for number 3?
8.92.
Oh, well, that's 4, but yep, you're totally right. 8.92. So
Oh,
number 4,
sorry.
it's okay, don't worry. So number 4 is 8.92 times 10 to the minus 4th. Minus 4. Whew. Number 3 is just 4 times 10 to the minus 4. All right. Yay, great job. Okay. So for the interest of time, sorry, y'all, I like teaching like distance is more difficult because it's like you kind of have to figure out what like fits best in the time slot. So, okay. We are actually going to touch upon how do you undo scientific notation? Like, what if something is in scientific notation and you don't want it to be? Sometimes that's a thing. The term we use for this is called standard notation. Standard notation. And my definition of this, again, this is not what you're going to see in your textbook, but standard notation is like when you undo the scientific notation. You know, it's handy to be able to write the width of the universe in a condensed form, but sometimes it's easier for us to compare numbers that are not written in scientific notation. So I wrote out a nice little chart of rules for y'all on the that worksheet again. So let me pull that up. Steps for standard notation from scientific notation. Y'all, literally, you're just undoing what you did to make it in scientific notation. So let's actually look at B. Let's do parts of B together. So B1, I'm writing this down. I will enlarge my document camera in a second. Two, 3. Alrighty, okay. Stop sharing. Okay. So we're gonna undo the scientific notation. And really to do that, all you're doing is really applying this power to our coefficient. So you know how if you multiply a number by 10, you move the decimal place over 1 to the right, right? So if I have 10 to the 5, remember that's like writing 10 times 10 times 10 times 10 times 10. All I'm going to do is move that decimal place over 5 to the right. So again, y'all, like, no shame. I do the little squigglies because I can't keep count very well. So 1, 2, 3, 4, 5. Between each squiggly, add a 0. I'm going to write it to clean it up because that looks a little gross. 1, 2, 3, 1. I have undone my scientific notation. So again, like y'all, standard notation and scientific notation are just inverses of each other. Okay. For number 2, 6.27 times 10 to the 3. Actually, let's make this a -3. So we have a good example of a positive exponent and a negative exponent. In this case, when we have that negative exponent, it's like we're multiplying by 0.1, right? So we move the decimal place over 1 to the left for each 0.1 we have. So again, in this example, it's like multiplying by 10. So we move the decimal place to the right. We expand it out at the big number. But in this case, our exponent is saying, this is a small number. Move decimal to left. Move the decimal to the left. So I'm going to move it over 3 to the left. So 1, 2, 3. And I'm going to fill in each of these little, what do I officially call that? I always just call them squiggles, but I know that's not an official chemistry term. I'm going to fill in each squiggle with 0. Then I'm going to rewrite it so it looks a little cleaner. So 0.00627. Long story short, y'all. Positive exponent, move the decimal to the right. Negative exponent, move the decimal to the left. Long story short, that's what you do. Questions about this? All right, okay. I want to go over one last thing before we call it a day. And y'all, for the end of this class period, what you'll notice is that on that shared worksheet I gave you, I would like for you to complete the last page for homework. So it's just a couple examples to reinforce what we just did. And for part C, this is, let me back up for a second. You're going to complete this last page for homework, and I'd like for you to complete it by the next class period. It's not super a lot, y'all, don't worry. I do want to go over one last thing before we conclude. All right. First off, questions at this point? We good? Okay. So what if you take some measurements and you put them in scientific notation because it's easier to read them that way if they're big or really big or really small. But what if you need to do some calculations with those numbers? How do you do calculations with numbers in scientific notation? So that's what we're going to look at. Rules for multiplying and dividing. And, sorry, I'm not making this a grammatically correct statement. Rules for multiplying, dividing, and adding and subtracting. Sorry, y'all, that's an ugly looking header right there. Again, I give you the rules in the handout. So let's look at that. Okay, this is going to sound like a bunch of gibberish at first until we actually go through an example. But first, to multiply numbers written in scientific notation, so like both numbers are in scientific notation, you multiply the coefficients and add the exponents. To divide numbers written in scientific notation, you divide the coefficients and subtract the exponents. So you might be thinking to yourself, this sounds eerily familiar to some of the rules we learned with exponents in math class, if you've gotten there in math class. If not, well then, hey, we just learned something new. To add or subtract, this is the tricky one. You have to adjust the scientific notation so that they have the same exponents. Let's look at some examples of this, because honestly, y'all, when I first learned this, I thought that these rules just sounded like complete nonsense until I saw an example. So example. First, let's look at multiplication. All right, so we have two numbers written in scientific notation, and we want to multiply them together. So 2.1 times 10 to the third, whatever, exponent 3, times 4.0 times 10 to the minus 7. So our rules say that we are going to take these coefficients and multiply them together. 2.1 times 4.0 to make our new coefficient. And then our exponents. We can't just ignore them. They have meaning. These exponents, when you multiply, are added together. So 3 plus a negative 7. 2.1 times 4 is 8.2. 8.4. Yes. Oh, God, y'all. Okay, yes. 2.1 times 4. 8.4. There we go. 8.4. This is our new coefficient. Times 3 plus minus 7 is a negative 4. So you treat the coefficients together. You treat the exponents together. And when you recombine your stuff back according to the rules, you get a new coefficient and a new exponent. Okay. Let's look at division really fast. And then, actually, you know what? Division is pretty similar to multiplication. I'm going to let y'all really try on those last couple problems on the homework. Really try to figure that one out on your own. So multiplication and division are very similarly related. In division, instead of multiplying your coefficients, you divide them. And instead of adding your coefficients, you subtract them. So I want to go over the addition and subtraction one because I recognize we're running out of time. So I want to cover that because I think that one is the harder one. So for addition or subtraction, you can't just multiply stuff together or like add or subtract the exponents. It's not like that. if you want to add or subtract, you have to make sure that both of your numbers in scientific notation have the same exponent. For example, if we have 5.4 times 10 to the third power plus 8 times 10 to the second power, these exponents do not match. You cannot just add the coefficients together. What you have to do is change one of these so that their exponents, the value in the power, match each other. So what do I have to do to this 8.0 to get it to be times 10 to the third? Would I move the decimal to the left or to the right? If you're unsure, here's what I recommend. Write out what would happen if you moved it to the left. Oh, no. That's going to give you the answer. Y'all, what I recommend, write this stuff out. If you're a little unsure, if you're like, does it go to the left or to the right? Write it out. Try it out. So let's say I move it 1 to the right. So now I have 80 times 10. This just made it to the 1. Do y'all see how if I move my decimal one place to the right, if we think about those original rules, how it decreases this by 1? Because these are the same number. Expand it out if you're unsure. What is 80 times 10? 800. What is 8 times 10 times 10? 800. How do I write this number, this 800, so that I get the exponent 10 to the 3? Well, if I move the decimal 1 to the left, what does that turn into? 0.8 times 10 to the 3. This is also 800. They're all the same number. It's just a different way of writing it. Okay, y'all. So I apologize. We got squished for time at the end. I understand if not everything has settled into the brain juices. Woodrow, do you have a question? Oh, okay. Sorry, just saw. I understand if not all of this has settled into your brain juices yet, and I apologize for going a little over time. But what I want you to do is on the worksheet on the last page, I'll also put this on Assignment Center. Go through A and B. I know y'all can go through A and B. Practice that reinforcement, right? For part C, try it. Look at the rules. See if you can figure out how to work the 3 problems in part C. You can't get it? It's okay. Just do your best. Think about it. I know we got rushed for time in the end. Okay. All right. Last minute questions. I'm so sorry I held you like 3 minutes over.
Ms. Duckworth, if
Yes.
we like handwrite it, should we just upload it to the folder? Like if we handwrite the homework?
Yeah, that's fine. So this I'm not actually checking for like necessarily submission. But yeah, honestly, y'all, if you just want to always upload your work to the folder, that's totally fine by me. Okay, we good? We good? I know that was like a lot of weird math rule learning. All right, okay, I've kept you long. Thank you so much for your patience. Have a lovely day.